live. From the Forestry Center in Cloquet, Minnesota, Bell Live presents Fire and the Forest. Come along on our electronic field trip as scientists take you deep into the forest to discover fire-scarred trees. We will climb to the top of a fire tower and see devastating fires such as those that occurred in Yellowstone. Learn as we investigate the effects of fire on plants and animals. And watch as we set ablaze a clear-cut stand of trees to experience the effect of fire live. It's Fire and the Forest, live. And here are your hosts, Peggy Knapp and Gary Lumpkin.
Hello and welcome to Bell Live's Fire in the Forest. I'm Peggy Knapp. I'll be your host for the show along with Gary Lumpkin.
Hi Peggy, and hi to you out there. Boy, we're gonna have fun today.
Welcome everybody. We are at the Cloquet Forestry Center in Cloquet, Minnesota. It's located about 130 miles north of Minneapolis and St. Paul. Now, at this center, one of the things scientists are researching is how do plants and animals deal with forest fire? We're going to be answering many questions about the changing role of fire in the forest. Now, this is a really good time to talk about forest fires. Many of you have seen wildfires burning out west, and maybe some of you have known firefighters who are out there trying to put them out. Well, doesn't it seem like you hear about more forest fires today? It's not that there are more forest fires, but because more and more people are building their homes deeper into the forest, more effort is required to put out those fires. So we're going to explore fire and the forest, but first we're going to meet some of you students who get to be with us here today. Maybe some future wildlife biologists, ecologists, foresters, or maybe even firefighters.
That's right, absolutely right, Peggy. In fact, these youngsters are here with us. These are our students, and they have a little message for you. You are?
Hi, my name is Micah. I'm from Columbia Heights, Minnesota, and I like to say hi to the Plymouth Middle School at the Bell Museum.
All right, Plymouth Middle School.
Hi, I'm Richard Reynolds. I'm Richard, and I'm from Cloquet, and I like to say hi to Duluth.
All right, hi to the schools. All the schools in Duluth on the line.
Hi, I'm Megan from Altoona, Wisconsin, and I'd like to say hi to Bev Stout in Indiana.
In Indiana. Hi, Bev.
And who's back here?
Hi, my name is Balva, and I'm from Duluth, and I'd like to say hello to Oakwood, Georgia.
Georgia.
Hi, my name is Carrie. I'm from Maplewood, and I'd like to say hi to Downington High School in Pennsylvania.
Hi, my name's Mike, and I'm from Edina, Minnesota, and I'd like to say hi to Malone, New York.
All the way to New York. We have people saying hi to you all over the country. Now, forest fires are generally kind of scary, aren't they? Well, not all forest fires are bad. They can even help a forest. They help a forest grow and stay healthy. Now, many years ago, nature played this role naturally when lightning strikes started wildfires in the forest. Do any of you remember Smokey the Bear?
Yeah.
Yes, Smokey the Bear, me too. Well, Smokey was a real black bear that was injured by a fire. And his message was to remind us that only we could prevent forest fires. 9 out of 10 unwanted fires are started by people, and that's what Smokey is trying to prevent. It's a great message, since none of us should just go out and start a fire. But what happened is that Smokey's message was so effective that every fire was immediately put out, whether or not it was threatening homes or people. And because of decades of aggressive fire control, today some forests are getting so old they're dying. And scientists believe fire is the missing link. When the sun can't get through the canopy of thick trees and reach the ground, new trees and plants can't grow. Branches are piling up on the forest floor, and pine needles lay like a thick carpet. Wildfires used to keep the forest cleared out so that new plants and trees could grow and provide food for the forest animals. Now, because fire can be good for a forest, we're going to show how scientists learn about fire and how it's used today as a forest management tool. We'll show you what a prescribed burn in a slash area is all about. It's also called a controlled burn, and we're going to find out why not all forest fires should be put out. Now, our forest fire expert who's with us here today is Paul Tenay. Paul, come on in. Hi.
Hi, Peggy.
Good to have you here. Tell us about your job. Now, you're a prescribed fire specialist.
That's right, Peggy. I work on the Chippewa and Superior National Forest in Minnesota, and my job here is to try to get fire utilized as a management tool in natural resource management for wildlife habitat improvement, timber sale improvement, and wilderness.
So you have to know about fires, forest, and how they fit together.
That's right.
What kind of education do you need for something like that?
Well, most of my education after I came when I joined the Forest Service, it's not something that you get a lot of in school, although a good background in fire ecology would help a lot. But most of it's kind of hands-on work that you get from experience.
All right. Well, since we have our fire expert here, and this program's about fire, why don't we take a few questions right now? Let's start with, I have some email questions that have come in. And this one's a good one. This one is from Heather Brown in Ramapo Ridge. She wants to know how many prescribed fires, like our fire, get out of hand.
Well, you have to understand that there is risk involved with prescribed fire. There's also risk involved with not doing prescribed fire, and that's what wildfires are all about. I can't give you a number on exactly how many have gotten out of hand, but I will say that yes, they do occasionally happen.
They do, and we're hoping that does not happen today. All right, we've got another email question from Galtier Magnet School in St. Paul. Alex Hawk wants to know, how long does it take to burn 1 square mile?
Well, that's kind of a fire behavior question that I'd have to get my computer out and calculate, but basically fires burn at a certain time called rate of spread, and if you've got a fire that's going at 1 mile an hour, it takes about an hour to do that.
All right. Do we have time for one more question? All right, well, let's move on to fire then. Many of you out there, and certainly Paul, you'll remember the Yellowstone fire from about 8 years ago. It's an example of an out-of-control fire, and we're going to give you a look now at this terribly destructive fire. In Yellowstone, the summer of 1988, the climate conditions were just right, and firestorms burned throughout the park. Nine 1,000 firefighters came to Yellowstone from all over the country. Fire crews from Maine to California, military crews and civilian crews kept that fire from burning famous landmarks and hotels. But in Yellowstone, nature's laws ruled. The wildfires raged on until the winds finally died down at the end of summer. This concept of naturally burning fires in a national park is new, but in nature's world, naturally burning fires are not new at all. More than 300 great fires have burned in Yellowstone over the past 10,000 years. You can see the calm attitude of animals and realize that they're used to wildfires as a natural occurrence, and they understand if and when they're in danger. All right, that's an example of an out-of-control fire. Now, Paul, is it correct to say that Yellowstone happened because too many years went by without a large fire because of that fire suppression and the forest debris built up?
That's right, Peggy. The area had quite a bit of heavy down material that was caused from bug kill, and over time that built up on the forest floor, and when it got ignited the intensities were just so great that it was just no way that firefighters could get close to it.
It's 8 years later. What does it look like now?
Well, I was there a couple of years ago, and you know, most of the area is lodgepole pine, and what I saw was little lodgepole pines about this high almost everywhere. They're coming back really nice.
So the forest really is adapted to wildfire.
Right. There's a number of trees that are specifically adapted to wildfire, like lodgepole pine, and they do just fine after it.
All right, good. All right, well, we have a demonstration for you now. An example of what happens when there's too much forest debris. So go ahead and show us what you got.
Okay. Our little tree over here is basically a balsam fir. It's a conifer like many conifers. It will burn, of course, because conifer needles have oils and resins in them which are flammable. But what really makes it go up is when there's a lot of down, dead material at the base of the trees that can get the heat to carry up in the tree.
And this is what happened at Yellowstone. Oh, wow.
Right, it's, you know, that fuel buildup underneath makes the fire go quickly up to the top of the tree, and when that happens, you've got what we call a crown fire. When a crown fire is going, it's pretty hard to stop.
And hot, too.
You bet.
So this is like a Christmas tree, so this is a lesson to learn. Your Christmas tree will go up if there's enough fuel around. And the message here is that when there's a forest fire like the Yellowstone, because all the fires have been put out for so many years, when a fire does happen, it may burn out of control because of that fuel underneath. And it gets so hot, it'll kill the trees and destroy the forest. All right, now remember the experiment that you may have done with the jack pine cone in the microwave in your classroom. Well, we have another forest expert here, and he's going to explain that experiment. Come on in, Bob. This is Bob Stein.
Nice to meet
All right,
you.
now what have you got here?
Well, I have some jack pine cones here. I have a couple of things. One is a branch off a tree. As the students remember, those cones were all closed that we sent them, and
Right.
This is the way they are on a branch. See all the way along here, a cone for each year, and they're still closed. Now, just like they did in the microwaves when they applied heat, this is a branch that came out of a fire. You can see the fire was warm enough and opened up the cones there, and all the seeds dropped out. So this happens in jack pine, happens in lodgepole pine.
So actually, jack pine and lodgepole depend on fire
Yes,
for
they
regeneration.
do. Yes, they do. That's the way they've developed in their natural conditions is with fire, they'll regenerate or develop a new forest that way.
So it's been around forever.
Yes, it has.
All right, well, we have our fire expert. We have our forest expert. Why don't we take some more questions from you? Do we have somebody in on the line?
Hi.
Hello? What? Can you still see us? What's your name and where are you from and what's your question?
Hi, this is Lindsay Levis and Jen Knoblich from Putnam Valley, and we want to know,
Are you burning all of it or just some of it? And if you are burning some, how are you going to stop it when you want to stop?
Okay, are we burning all of this area? Are we burning some of it? And how are we going to stop it?
Okay, well, I'll take that question. In fact, you'll see later on in the program how the answer to most of that question. We're not going to burn all of it at once. We'll burn just part of it. We have several ways of stopping it. We've built fire breaks around it where we've scraped away all the stuff that will burn down to just mineral soil.
Right, and
Plus,
some of this we're going to show you in
right.
just a minute.
And then we'll also show you firefighters who eventually will put it out using water.
Right, so we're taking a lot of care with this. Do we have another question out there? We have somebody on the phone?
I'm Teresa
Hi, Teresa.
Henderson
Where are you from?
from the Denver Museum of Natural History.
Great, and what's your
And
question?
I am wondering, how long does it take to grow the vegetation to grow back after a forest fire?
How long does it take the vegetation to grow back after a forest fire?
Go ahead, Paul, if you want to
Well, immediately you'll see vegetation coming back. We had a fire last year in the Boundary Waters canoe area, and I was out there literally no more than a month after that fire burned, and there was already young jack pine seedlings about 1 inch high growing 1 month after the fire. Grass comes in right away, and then the trees start coming in, and it'll be green the next year.
So you can see from that the forests are adapted to fire, and they'll immediately start to regenerate.
That's right.
All right, good. Do we have one more question out there on the phone? Who's there? We're going to take an email question now? Okay, we've got another one right here. It's from Bain Elementary in Kenosha, Wisconsin, and Beverly Byers' class wants to know, how hot do fires get?
Well, there have been some readings taken on fires close to 2,000 degrees on a real
2,000 degrees?
Right, on a real hot burning fire. Now, a fire like that is one that you can't fight up close, and usually it's going to be less than that. But some of the big roaring crown fires that you see, it can be as hot as 2,000 degrees.
Wow. What about underneath the soil? Does it get that hot down where the roots of the plants are?
No, actually the soil itself is a pretty good insulator, and it's cool down there, and normally it's moist, and so that for heat to penetrate down there, it's really what's more important is how long the fire is burning there rather than how hot it is. A lower burning fire can actually cause more damage than a hot burning fire if it stays on there longer.
So you want the fire to move through.
Right.
All right, we're going to show you this prescribed burn now, and we're going to show you a picture of the area that's been prepared for us. Now, Paul, what kind of conditions have to be right before we would go ahead and light this fire?
Well, every prescribed burn has a prescription written for it, and the main part of that prescription is the weather parameters that go with it. In this case, we want to have the temperatures probably in the 70-degree range or less, which we've got.
Which it is.
We want wind speeds of less than 15 miles an hour, and looks pretty good on that. And our relative humidities shouldn't be any less than about 25–30%.
And if those conditions aren't right, you don't burn.
That's right.
Okay. Now, why would the Cloquet Forestry Center want to burn this area?
Well, this area that we're going to burn was a jack pine forest here that we've harvested, and what's left is what we call the slash, which is all the tops of the trees, the branches and so forth, they're left over. And so we need to get rid of that before we can begin growing our new forest. So the fire will get rid of all that slash.
And it'll prepare it for the new one.
Yeah, exactly. Plus, since it's jack pine, we talked about these cones opening. As the fire goes through, it will heat those cones, the seeds will drop out, and we'll have all kinds of young jack pine growing up here again.
Oh, sure, so it'll regenerate itself.
Exactly.
All right. Now, we also would never light this fire without taking a lot of safety precautions. So, Paul, tell us about some of those.
Well, probably the main safety precaution is that you don't do a prescribed fire with anybody who isn't a trained, qualified firefighter, and that's what we've got out here today. After that, then they're going to have all their equipment with them, and then, like Bob was mentioning earlier, we put fire breaks in around the area to burn, and that's to keep the fire from going outside of the area.
What is a fire break?
It's an area where something, either people with shovels or heavy equipment, have taken and scraped down to mineral soil. That's the soil that will not burn, and cleared that out so that there's no fuel that can come across.
So it's a little buffer.
That's right.
All right, and we've got the machine that cut that fire break running right over here. It's called a skidder, and Gary Lumpkin's over there to talk about that.
Well, you're absolutely right, Peggy. The skidder, you're watching it operate right now behind me, and it just does that. It just skids all the slash and stuff and puts it into a manageable area and cuts those fire breaks. So that's one of the pieces of a safety equipment, and safety is good. That's good, John. Thank you very much. We'll cut that down. That's a noisy piece of equipment. You know, and we talk about equipment and safety. We have a number of firefighters. We're going to get the chance to see them in operation. And some of the equipment they use, we'll show you right now, and you're maybe a little bit surprised. For example, I want you to take a look here. This is a fire truck you're looking at right now, and it looks just like a white pickup with a bunch of stuff in the back end. Well, that's what it is, but even though it doesn't seem real big, this is one of the tools that the firefighters use. Now, this is Vern Northrup here, one of our firefighters. I'm going to interrupt you just for a second. Sure. And you know, I know the kids are wondering, I mean, this doesn't look like much of a fire truck.
No, it's not. It's specially designed for fighting wildfires in the woods.
But how much water can it hold? Because there's no hydrants out here.
We carry about 250 gallons of water.
And that doesn't seem like it would go very far.
No, it doesn't, but we kind of enhance that. We use a foam solution.
A foam?
Yes, it's like dish soap, and actually it helps the water stay on the woody material better, and it penetrates the wood better.
Better than just water would by itself?
Yeah, it's kind of like, we call it wet water.
Okay, wet water, huh? It makes it working better.
Makes it work better and extends the amount of water we have.
Okay, good. Well, I'm going to let you work here just a little bit more. In fact, why don't we just demonstrate here in a little bit right now, just the spray with this particular hose.
Well,
okay.
I'm going to have one of my crew members fire up the pump.
Okay, you're going to fire up the pump. And so remember now, this is only 250 gallons of water, but this foamy substance that goes with it, kind of like dish soap, okay, makes it so that they can get a lot more miles out of it. It makes the water wetter, if you can imagine that. And you can see that he can adjust this spray. He can make it a long-distance spray. He can make it spray out in a more fine pattern. And this will cover a tremendous amount of area. Okay, good. Thank you very much. Yeah, I guess another way, and I had a chance to talk to Vern before, if you can think of, think of this microphone as a piece of wood. If it was just plain water, the water would just run off or might even evaporate. but put a little soapy stuff in it, the water actually sticks to the wood and does its job. It makes it wetter, sticks to the wood, puts out the fire. It's just that simple. Kind of clever, huh? You know, I want to show you some of our other students here right now, and you notice they have put on some of the gear, the yellow shirts, the hard hats, they have the pants, the boots, and all that. Now this material makes them more visible in all the smoke and the haze, which is important, but it's also, of course, fire retardant, fire resistant. And this is one of the things that they can do. And they're also putting on these backpacks. How heavy is that? Does that feel heavy?
Yeah, quite a bit.
It is heavy. In fact, I'm going to give to Vern right here. Vern, how heavy is the backpacks they're putting on?
They carry about 5 gallons of water. It makes it about 40 pounds.
40 pounds. Now what this is, this has this mixture. We'll get you to turn around here. Just turn this way so yeah, there we can see it in the back. And this is full of that solution, so one firefighter can cover a lot of ground?
Yes, we work them in teams with 2 together, and one will knock down the bigger flames, the other one will follow up and knock down the smaller flames. So it's a pretty disciplined way of putting out the fire.
Okay, in fact, one of the questions we had, and thank you for the question, this came to us from Pinewood Elementary over the fax, I believe. Pinewood Elementary in Monticello, Minnesota. And they want to know, how heavy is the equipment? Well, we know that backpack is about 40 pounds. Do you carry other stuff too?
Yes, we carry our own day packs, our food, and our own drinking water. And so we carry quite a bit of weight when we go into a fire. We carry sometimes up to 100 pounds.
So you got to be in good shape.
Yes, you have to be in real good shape.
Okay, let me ask one of our students here. You think you could, now you've only got 40 pounds on. How'd you like to add about another 40 pounds and hike up the hills?
I don't think I could do that.
It'd be tough, wouldn't it? Yeah. We'll have you demonstrate how the sprayers work right now. You will just kind of spray them out in this direction over here. And you can see just a little pumping action, okay? Not too tough, huh?
No.
Okay. Maybe you guys can water the lawn at home after this, huh?
Yeah.
Yeah, okay, good. I'm not sure the soapy water would be good for that, but that's how it might work. Oh, you know, we have one other cool thing we got to show you. Why don't you slip the pack off, because we talked about the heat of the fire a minute ago, and sometimes it can get into up to 2,000 degrees, and sometimes firefighters, unfortunately, get into a position where the winds change and they have to, do something to protect themselves. And Vern, what do we have here?
This is a practice fire shelter. This is actually what we carry on ourselves. This is one we practice with.
Everybody carries one of these?
Everyone carries this on a wildfire or forest fire. This is our practice one, and I'll show you the real one
Okay.
we carry.
All right, you carry one like that. Okay.
Carry one like this.
While he does it, you talk him through it and tell us what's going on.
He's going to step inside that, literally step inside that, and it's like a small pup tent. And what it does, it keeps the hot gases and the smoke away from him. And they're aluminized, so they reflect the heat away from him. Like you said before, the temperature gets up to 2,000 degrees. And this is kind of like a last resort. We try to keep everything in prescription, so we never have to use this. But these are a proven lifesaver, and we do sometimes, unfortunately, we have to use them.
Now, so what would happen is he's going to step inside there and kind of just make a little tent over himself.
Yep.
And then what happens then? How does this, because this doesn't seem like this would protect you from a hot fire.
Yes, well, what it actually does, it just makes an air pocket around you. And you're going to have to kneel down.
Okay, there he goes.
Okay, and then...
And he's trapping the air inside?
He's trapping the air inside, and that's all it does. It just keeps that air pocket around him. And the aluminized outside.
Okay. Now you've been a firefighter how long?
For about 10 years.
So you fought a lot of fires?
Yes, I have.
Have you ever had to do this yourself?
I've come out to a point where I pulled it out into my hand, but fortunately the weather changed for us.
So it's something, it really is a last resort.
It is the last resort.
So even somebody with your experience hasn't had to use it, but if you needed to, you could have.
Yes, I could.
All right. Well, you can see we're totally stressing safety here, and they've got all the safety and all the firefighters here, and we're just about ready to put those firefighters to work as we're going to start our prescribed burn. Peggy?
All right, again, conditions are right today for our prescribed burn, so it won't go out of control and it won't jump the fire breaks or get too hot. Again, the intent of this burn is to burn slash, stuff left over from logging the trees. But we don't want it to spread to the trees that you can see behind us. So all these precautions are in place. Now there's a couple of different kinds of prescribed burns. Like I said, this is a slash burn, but the other kind is called...
You do an underburn.
An underburn.
Yes.
And that's where you burn the understory or the underbrush from around the trees and you try and leave the trees standings. Okay, but this is a slash burn. Now, Vern, why don't you come on in and I'm going to have you explain this torch that you're using that your firefighters will start it with.
This is a drip torch. This is actually what we're going to do the ignition with. This carries a mixture of gasoline and kerosene that we we dump out, it comes out of this tube, flows around and goes over this burning wick, and it drips off, it drips literally liquid fire, and it's real easy to start a fire.
Oh, so once the wick is burning, the fuel oil drips past it and lights and hits the ground.
Yeah, we turn it upside down, and we adjust the flow by this air valve here, and it drips right over it.
All right, well, why don't you give your firefighters the signal to go?
Okay.
Okay, so we're going to start the firefighters lighting the fire. We're going to take a look at that as it burns. And while we're doing that, I want you to get your prediction sheets out, and we're going to try and calculate the rate of spread of this fire. And what you should know is that the poles are 10 feet apart. So you'll use that to measure the rate of spread of this fire. Now you can see the fire has started to get going, and while we're watching the fire burn, we're going to start taking some questions from you. We have somebody on the phone right now. Who is out there?
Should I talk?
Yep, go ahead.
Okay. This is Rachel Paisley from the Denver Museum of the Natural History.
Welcome. What's your question?
And I was wondering what would happen if the controlled fire came out of control?
All right, we're hoping that doesn't happen, but they want to know what happens if the controlled fire gets out of control.
Well, for every prescribed burn that you do what's called a holding plan, and then you do a contingency plan. The holding plan is the resources that you have on hand that are going to keep the fire within the fire lines that we have out here. Then your contingency plan involves what would happen, just like what you said, if the fire gets across the line and get someplace where you don't want it. Then you need to have that many more resources on hand to be able to take care of that fire. In this case, we've got quite a few resources. We've got our Bombardier J5s out there. We've got a big tank truck over on the side and enough firefighters to do the job.
So you always have a plan B?
Right.
Okay, good. All right, we have an email question now from Marcy from Marcy Open School in Minneapolis. They want to know, how do most of the fires get started?
Well, unfortunately, most fires are started by people through carelessness.
More than lightning
More
strikes?
than lightning, yeah. Lightning only accounts for maybe a third of the fires totally, but people start most fires, and those are the ones that we'd really like to not see happen. The lightning fires, of course, you can't do anything about those, and sometimes they do what nature wants it to do, but it's most of the time the people cause fires happen at the wrong time in the wrong place.
And how are those fires started? Is it deliberate or accidental?
Well, unfortunately, some of them are deliberate. There could be arson involved with some fires. Others are started by carelessness, kids playing with matches. Debris burns getting away from a burn barrel happens quite a bit here in Minnesota. And then other times it might be from things like power lines getting blown down in a windstorm or things like that.
Okay. Do we have another phone question out there? No? All right. Let's take another look at our fire, and we'll get another email question in. Okay, here's one from Sheridan Elementary in Wyoming, and they want to know out in Wyoming, how long does it take to train to be a firefighter?
Well, first of all, you have to be 18.
So it takes at least 18 years.
You got to be 18, and then every firefighter goes through a minimum of 32 hours of training to be a firefighter. That's the minimum amount of training that you can have. Some first-time firefighters on some of the elite firefighting crews take up to 80 hours, but 32 hours is your basic firefighter training.
And that's a lot of physical conditioning and understanding fire behavior.
Right. Well, the physical part is a whole separate thing. They have to pass a physical fitness test no matter how much training they have. They have to be physically able to do the job as well.
All right. Now, we're going to give you a time on the rate of spread as soon as we come back. Have we gotten to the polls yet? Doesn't look like it. All right. We're going to give you some questions now, which I hope you can answer. We're going to take a short break, be right back, and when we get back, we'll give you the time on how long it took to get from one pole to the other, which is 10 feet apart. We'll be right back. take a look at our fire now just to check in and see how it's doing. Paul, what do you think?
Well, it's looking real good, Peggy. You can see the smoke's going straight up, so that means that we don't have any kind of problem with too much wind today. And because of that, what's happening then is that the fire will tend to pull toward itself. So we're putting another line of fire through here now.
Yeah, right behind us.
Yeah, well, it'll warm us up a little bit. But otherwise, it's doing just what we want. It's not running too fast, and the flame lengths are such that we should be able to keep it under control.
So you'll create a fire all the way around and then it'll burn into itself.
That's right. That's called a ring fire, and fire will tend to attract itself if it's not being blown too hard by the wind.
Okay. Well, here at the Cloquet Forestry Center, there are lots of kinds of research projects that scientists from the University of Minnesota and other forestry centers are working on every day. And this center was started in 1910, and it's one of the oldest experimental forests in the United States. Now, some areas that were planted during the center's early years are still being evaluated and will be evaluated for years to come. One of those areas is called the Old Growth Forest, and Gary Lumpkin is out there right now, deep in the forest. Gary, are you there?
I sure am, Peggy. Deep in the forest is absolutely right. And the old growth, I mean, it gets its name honestly because I am in an area that is, well, take a look. These trees are they just go straight up to the sky, hundreds of feet, well, maybe not hundreds, but it seems like it, up to the canopy. It's absolutely gorgeous. In fact, they tell me some of these trees are well over 100 feet, maybe, are 300 years old. The average age, in fact, is about 170 years of age. That's just the average, and they are absolutely magnificent. And they do a number of research projects here. In fact, I want to have you meet one of our research scientists here. This is Geraldine Thompson, and research scientists more specifically.
Well, Gary, I'm a research scientist and a forester in the College of Natural Resources at the University of Minnesota.
So you study trees, I guess. That's the best thing to say?
Well, that's
among
right.
Other things.
So I'm a scientist, and by nature, scientists are very curious, and we look for clues to find answers to a lot of different questions. And we don't just go out and find an answer one time. It takes a lot of knowledge building, a lot of scientists giving input into discovering answers.
We know, I have a question. We've talked about fire. In fact, we have our prescribed burn going now. And I understand how fire can be good, but it occurs to me that doesn't it just burn down all the trees? I mean, how come the trees don't just all burn down?
Oh, well, because some of these trees are too big and there's not enough fuel to light them, but trees are very resilient to fire. This is an example of a fire scar right here. You can see this tree has been burned many, many times. If we take a look down here, we see that the deepest scar is when this tree was first burned. It burned and then it healed itself up.
See, I can see the scar, and I bet the kids can too, the students, but I would assume that this is all just one fire, but this is several fires?
Oh, several. Yes, you can see it. It heals itself up, and then it grows again. It has another fire, heals it up. You can see how it's calloused all the way out to here. So this tree actually experienced 5 different fires. Okay, if you take a look at the stuff behind us, you can see that there hasn't been fire back in there for over 100 years, and all of the trees in the understory have grown up, and so the red pine are not going to be able to reproduce.
That was my next question. These are all red pine?
These are red pine, yes.
Okay, so you can tell a lot from just how the burns and stuff like that, how old a tree is?
Yep, and you can tell the direction that the fire came. The fire came this way, and it's hottest on this side. Let me show you something else over here.
Okay.
Megan has a great big cookie, is what we call it. It is a cross-section of a tree, and we can learn a lot from just looking at this stump. There's a few things that I can tell you. We know that this tree was cut down in 1982, and we know that this tree is 192 years old.
How do you know that?
Well, you start at the very center. You see there's a little tiny circle, and you count the concentric rings from the smallest one all the way out to the edge.
So you're counting those lines?
We're counting those lines.
And each line is?
Each line represents a year of growth. And you can see here that you can see the effects of the fire scars on here. This was one of the mother trees that helped this whole stand get started. You can see that 1824, excuse me, this whole stand was established from fire.
Now this was cut down when?
In 1982.
Okay, how old are you, Megan?
14.
So you were born
1982.
1982. So you're right here. Your ring is right on the outside.
Yep.
Okay. My ring is, well, we'll talk about that later. Is that okay? We'll go with that. So that's cool. So you actually have ways of finding out how old a tree is.
Oh yeah, but fortunately, every time a scientist wants to know how old a tree is, we don't have to cut a tree down. We have other tools to use to find out that.
Well, let's see that.
Okay. Carrie is over here, and she has got an increment bore, and that's a tool that foresters and scientists use for measuring the age of trees when they're alive. So she's going to pull this core out very carefully. There you go, Carrie. And you take a look and see, yep, she got to the very center of the tree. It's very important to get all the way to the center of the tree.
Let me hold that up here real quick. Okay, now tell us what we're looking at.
Okay, what you're looking at is all of these little lines tell you a bunch of different stuff, actually. It tells you how old that tree is, and it also tells you how fast it was growing.
And why is that important again?
Well, it's important for a whole lot of reasons, Gary. And let me show you another thing, and then we'll kind of talk about the whole package together.
Okay.
Mike here has got another tool that foresters and scientists use, and this is called a caliper. And a caliper is used to measure the diameter of the tree. So he opens the jaws, and then about 4.5 feet up, he squeezes it tight.
And I'm going to step across you here. Can you read that? What is it, Mike?
17.5 inches.
Okay, 17.5 inches. Obviously, I know that's going to be the diameter. And what do you know from that now?
Tree. Well, we know a whole lot of things. We also measure the heights of these trees, and we look at the landform. Foresters and scientists do a lot of inventory work. That's one of the first things they do when they need to make a management plan for an area.
Okay, all right, good. Well, thank you very much. So scientists are curious and answer a lot of questions.
That's right, and there's scientists in all of us.
Okay, good. Thank you very much. Well, you might be interested in curious about things. Maybe science is something you might want to consider. In fact, we have a curious, we have a question right here that will tie into what we're going to ask about next. Josh in Tranberg Forest Park in Kenosha, Wisconsin, faxed us a question. He says, wants to know about what animals, how they do in forest fires and animals in forest fires. And that's really good to know because, we've talked about how trees are resilient and actually can survive forest fires. Forest fires might even be good for certain parts of the forest, but the animals are a totally different question. Well, fortunately, we have an animal expert here. I'd like you to meet Mary Lou Martin as a naturalist. Would that be correct?
That's what you call somebody that tries to teach people about nature, and we're going to do that right now.
What do we got?
We have Spike the porcupine, and Mike is going to pet him on the head, which is a very unique experience because it feels a little bit like heavy-duty hairspray. Those quills are laying down under the fur.
That was sticky.
Well, it is a little bit sticky feeling, too, I think Micah can tell you.
How was that?
It felt a little weird. It felt like a brush or something.
All right, good.
Good explanation.
But
I
now,
like a scrub brush.
What about Spike? We have a forest fire. What's Spike going to do?
Hey, we've got very tall trees around here. He is one of the best tree climbers I know. He'd be up to the top of the tree and quicker than I can tell you about it practically, and he might be safe. If the trees don't burn, if just the understory burns, he's going to be okay up there, maybe getting a little smoke, but maybe doing just fine.
Okay, so they've got a way of getting out of it. Now here are owls that I see. I know it's an owl. I'm not sure what kind. They just fly away, I suppose.
Well,
right?
we have a barred owl here and a great horned owl here, and yes, you're right. They would fly away whenever there was hint of danger, and they might even benefit in kind of a strange way because if they're sitting at the edge of a fire and all the rodents are trying to escape, they're going to have a banquet set before them. They're going to catch anything they can catch and probably pig out pretty good.
So once again, the fire may actually help these
Could
animals.
help these two in amazing ways.
Okay.
A banquet.
Very interesting. Okay. Now we have some other animals that can't fly away, can't climb a tree.
Well, let's say they could crawl. This one would be mighty slow. Lydia's holding a western hognose snake she's trying to keep warm, and that's a very interesting snake face, I have to say. Now, this is a small snake, can't move very fast, might not make it, but this one, a Minnesota bull snake, is a lot bigger, and that could move a little bit quicker. Another thing that could happen is there could be a fire when the snakes are already in hibernation, and if they were underground and the ground was not superheated, they might be just fine down there. So that could be another possibility for a snake.
Okay. So what happens? You're saying they would burrow down into the ground.
That's what they do during hibernation here in Minnesota. It gets pretty darn cold in the wintertime, and that's what I'd like to do, as a matter of fact.
Well, that ties in with what we learned earlier and talked about how the ground doesn't necessarily get all of that hot and the roots and stuff stay moist. So the animals that can burrow, they actually have a pretty safe place.
It sounds like a very safe place. That's what I'd choose.
So once again, we've learned how animals not only we learned how animals can not only escape from the fire, but can actually perhaps even benefit by making food more available and stuff like that. I want to bring in I want to bring in Geraldine again once more here, because this is a good time. Actually, before I bring in Geraldine, I almost forgot. We have one other animal that we better consider here.
Oh, that's true. We can't forget Smokey.
That's right, Smokey. We'll bring in Smokey. I almost forgot Smokey.
Elvira just gave Smokey a big, dirty look and decided to try to fly again. I really am sorry about this, but this is live TV. Nothing we can do about it.
Right. Now, Smokey, a bear like Smokey.
Another tree climber. Although he is a little bit overweight, he might have a little trouble getting up to these trees.
Smokey, you can climb the tree if you had to? Well, Smokey's not so sure. But there, once again, the bear, some can climb, some can run away, some can fly and maybe wait for things, burrowing. Animals have a way of adapting.
Lots of possibilities.
All right, let me bring in Geraldine again, and I think we have a chance now for perhaps some other questions from some of the students out there watching the broadcast. Yes, go ahead. You have a student on the line?
Hello?
Hello, yeah, ask you. Who are you?
This is Brian Higgins, Bobby Bannon, and Nikki Riley from Putnam Valley Middle School in New York.
In New York. Okay, all the way from New York. Great. What's your question?
And our question is, what are you going to do with the land after you have burned it?
Okay, now they have a question about what they're going to do with the land after we burn it, and our experts are, well, actually, you could probably help us with that. The land after we're in our clear burn area, what are they going to do with that land?
My guess is I haven't been over there to that site, but my guess is they're going to regenerate it somehow.
Okay. We're getting rid of that slash and all that ugly stuff.
They're preparing the seed bed so a new generation of trees can be planted or reseeded in naturally.
Okay. So we'll have a whole new forest there in a few years. Yeah, we have another question. Thank you for your question. Go ahead.
Hello.
Hello?
I'm in Jason Franks from Buena Vista Elementary.
Buena Vista? Okay, is that Buena Vista Elementary?
Alamogordo, New Mexico.
New Mexico. All right, Alamogordo. Go ahead. What's your question?
How many fires can a tree live through?
How many trees? No, I probably should say that the other way. How many fires can a tree live through?
Well, that's a good question.
That one did like 5.
This one lived through 5. You can live through many. It depends on the age of the tree and the intensity of the tree and how healthy the tree and the stand is when the fire comes through.
So it could live through bunches of fires.
Many fires.
Or if it got to be a really bad one,
then it might be the end of that particular tree. It could be the end of the whole stand.
All right, we have one more. I think we have an email question here. Let's see. This one came in. This was from Challenger Elementary in Thief River Falls, Minnesota, and it says, smoke can kill humans. Will it kill animals too?
Yeah, certainly. The smoke could kill any of the animals that we see here today, and the fumes, the carbon monoxide that we have to worry about inside our homes can be a danger, and all those things are just as harmful. We're sharing the earth with these animals. We have to have their concerns too.
So smoke could be just as bad for us. Well, thank you very much for your questions. We'll have chances later in the program to answer even more of your questions, but I think it would be a great time now to check back in with Peggy and see just how well our prescribed burn is doing. Peggy?
Well, it's nice and toasty here, that's for sure. Bob, how's our burn doing?
Actually, Peggy, our burn is doing very well today. You notice that we burned almost in the entire area that we wanted to. We were able to burn up most of the slash that we talked about, the branches and so forth out there. So we'll be real happy with this controlled burn, partly because it stayed in control.
I was going to say partly because it is controlled.
Yes.
All right. It's getting very hot though. Vern, can you kind of cool it down on this side? Don't put it out yet, but just cool it down. All right. Now we have looked at fires pastoral and what happens when fires are suppressed too long. Now we want to find out how we can manage the forest today. Obviously, we can't let fires burn out of control, especially when people have built houses and buildings deep into the forest. So scientists have to figure out how to keep the forest healthy and fit all of those different pieces together. The different pieces we're talking about are keeping the forests for wildlife, recreation, and of course a society that wants wood for wood products. In your curriculum, you learned about all the different kinds of things we make out of wood. So let's take a look now at how paper is made. When you see something like this, it's called a clear cut, the kind of area we're burning in our controlled burn area. Every tree in the area is logged and transported to a landing area by using a machine called a skidder. On the skidder is a grapple that grabs and holds the logs. Next, the logs are loaded onto a truck and hauled to a place like a paper mill. At the wood yard, huge cranes unload each truck of logs. At this paper mill, approximately 2,000 pickup trucks full of wood are used every day, 7 days a week. The next step is called chipping. All the logs are crushed into wood chips, each averaging 3/4 of an inch long. And this is the first step in the manufacturing process of paper. Inside the plant, the chips are fed into a machine called a hydropulper to make, yes, you guessed it, pulp. At this point, the mixture is 99% water and just 1% fiber. As the pulp is carried along, the fibers are aligned and water is drawn off by gravity and suction devices. Within seconds, the water content drops to 80% and the pulp is converted into paper. These paper rolls weigh 40,000 pounds each, and if you stretched them out, they'd run 22.7 miles, almost a marathon. So a heavy-duty crane is needed to change the rolls. Next, the paper rolls are cut, stacked, and covered. This paper mill produces fine-coated paper for books, brochures, and posters. Now, we've talked about how timber companies clear-cut the forest area, but many times they cut only certain trees from a stand, and that's called selected harvesting. The foresters mark the trees they want to be removed by painting orange marks on the trunk. This makes it easy to identify which trees will be cut. When these trees are harvested, it will make room for new trees to grow and will result in a very limited habitat disturbance. Now, logging can be very controversial, especially when it involves certain species of trees, like the white pines in Minnesota or the redwoods in California. Now, you may have heard about these controversies in your class or on the news. In Minnesota, there's a stand of white pines that are diseased and dying because they're so old. Now take a look at this. This is called blister rust, and it's on some of the white pines, and it's killing those trees, and it will spread to others. The controversy is whether or not to allow a certain number of those trees to be cut for their wood, or should we just leave them alone? Now in Minnesota, a compromise has been reached, and if you did the Lullaby Lake classroom exercises, the decision that was reached closely mirrors your alternative 4. And that compromise involves logging some of the white pine and replanting the area with more white pine, and then managing that whole area more effectively for fire and disease control. Now, from all of this, you can guess that the timber industry is a very scientific business, as is forest management. So we're going to see more of that science right after this. We're going to take a short break, and we have some more questions for you. All right, we're going to take another look at how our fire's doing. Paul, what do you think?
Well, it's looking pretty good, Peggy. We're just winding down now. We've gotten good consumption, as Bob said, and for those folks out there that were timing, when it was really going at its most, it took about 4 minutes to get from one post to the next.
Okay,
so you
4
can figure
minutes
that out.
for 10 feet.
Right.
So you figure out the rate of spread. Okay, good. We're going to go out to Gary Lumpkin now. He's at the fire tower, so we're going to give you a look at what that is. Gary?
Well, Peggy, I am just now getting to the fire tower. In fact, it's a, next time you can do it. It's quite a climb. In fact, let me show you another view of where I am now, because I am on top of the fire tower you're looking at right now, and it is some 70 plus, almost 80 feet up in the air. And as we just heard, a fire tower is a good way to just for fire observers to kind of scan the horizon. I have Megan here with me right now, and it's not a bad view, is it?
Oh, it's wonderful. You can see for miles over the canopy.
Absolutely, and of course we have even a enhanced view of that we have an aerial shot that you can take a look at. And as you look at that, you can see various places where the area has been clear cut and trees are starting to grow back. In fact, we can see that from here, can't we, Megan?
Right, you can see the difference between the old growth, which is the taller trees, and the new growth, which is the shorter trees, which aren't quite as fully developed.
But even then, even with the old growth in comparison with the new growth, you can see where the trees have started to grow back, and these were cut down about 8 to 10 years ago.
Right. And then there's a clear-cut area, which is right over there, where not very much is growing at all.
Yeah, and it won't be long before that, in fact, does regenerate itself, and we have more forest. You know what would be fun to see is if we can see our fire right now, and I'm not sure the camera will pick it up. I'm going to turn you back this way, Megan, just a little bit, because it's right over there, and once again, I'm not sure our camera can pick it up, but can you see it?
Oh, I can see it perfectly.
Yes, we do. Oh, good. They're telling me that they can, in fact, see it. We see it well, too, don't we?
Right.
So once again, a firefighter, an observer up in this tower wouldn't have any problem seeing fires from miles around.
Right, even farther away from where our fire is, they'd still be able to spot a fire.
Yeah, especially on a wonderful day like this. Well, I got to tell you, this is a great view, and Megan and I think Peggy will just hang out here and watch this, because this is too good a piece of scenery to pass up. Don't you agree?
That's right.
All right, so back to you on the set, and let's check in on our fire with Peg.
Well, Gary, I don't envy your effort to get up there, but you sure have a great view. Now, Bob, it looks like they can just see everything up there. Why don't you use those fire towers anymore?
Well, it is true. You can see a very long distance from the top of a fire tower, but what we found out is that since those people are stationary who would be up there, all they can see is what they can see from the fire tower. We found out that by putting people up in a small airplane, they can fly a regular route, and they can see hundreds of miles from that airplane. And so what they do is go up, and they can cover far more distance with only one person doing that. Plus they have flexibility going up on, depending on what the weather's like each day, whether they need to go up and spot fires or not.
Oh, all right. Well, we have time for a few more questions. So is there somebody on the line, or can I do one of these email questions?
Hello?
Are you on there?
Yes.
Hi, what's your name and what's your question?
This is Jenna Simmons from Body Middle School in Milledgeville, Georgia.
Welcome. What's your question today?
How long does it take to repair the damages of a wildfire?
How long does it take to repair the damages of a wildfire, Bob?
Well, actually it may take decades to do that. Again, depending on what the damages are. If we have a devastating fire where all the trees have been killed,
like Yellowstone.
Like Yellowstone. Well, actually the forest itself starts recovering almost immediately. Even at Yellowstone, new plants started growing up. The trees will start growing. It may take years and years before we see trees the same size as what was there, but nature heals itself quite rapidly. It starts immediately after the fire.
Wow, great. Okay, we have another person on the line. Who's out there, and what's your question?
Danielle Macklin.
Hello, Danielle. What do you want to know?
I was wondering, does the smoke from a large forest fire damage the ozone layer?
Oh, that's a good question. Does the smoke from a forest fire damage the ozone layer?
No, smoke from forest fires has been around since before anybody was here.
Before we knew about ozone.
Before we knew about ozone. Smoke is a problem, though, with people, people who have respiratory ailments and disease and things like that. If they get smoked in a city or a town from forest fire smoke, it can cause a lot of problems with them. But it's not a problem to the ozone.
Okay, because fire's been part of the environment
Right.
for tens of thousands of years.
The whole world evolved with fire.
Okay, we've got an email question now from Nick at Purdue University. He wants to know, how do firefighters clear all the debris out?
Well, I'll take that one. In fact, the reason we have fire is to get rid of debris. And again, if the students can see back there, about what's left is ashes and small pieces of wood. And so we don't worry about that. In fact, there's some nutrients in that eventually settles back into the soil. And so we will go in and plant, or seedlings will come up, and actually we don't worry about debris that's out there. We leave it there.
Because it'll just degrade by itself
Exactly,
eventually.
yes.
And become part of the soil in the forest floor. All right, from Terry Henry in Sheridan, Wyoming. For liability reasons, I imagine kids can't help fight the fires. Can kids help in other ways?
Well, first of all, you're right about the liability. You have to be 18 years old to be a firefighter. But I think the main way that kids can help is to listen to Smokey and be careful with your matches and with your fires. We really are getting to the point where we understand how important fire is in nature, but we don't want those unwanted fires, so if you can help us by keeping those out of the woods, then we'll be a lot better off.
So the biggest thing is don't start a fire.
That's right.
That's the big thing. Okay, we have a couple of phone questions now. Who's on the line out there?
Betsy Good.
You're going to have to speak up, hon. I can barely hear you.
Betsy Good.
Hi, what's your question today?
How hot does it get underground?
How hot does the fire get on the ground?
When the fire is burning?
Uh-huh. Okay, how hot does the fire get, and how hot will the ground get? We'll just take both parts of that.
Well, that's a good question. Temperatures from a real hot fire can get almost to 2,000 degrees.
2,000 degrees?
That's right, and that's those very, very hot, catastrophic type wildfires. However, the ground itself is cool and usually has some moisture in it, and if the fire goes over it very quickly, that heat will not penetrate down into the ground and won't do any damage. It's when a fire is very long lasting that the heat penetrates down into the ground, and then you have soil damage.
Now the soil is a fairly good insulator as well, so the roots don't necessarily die.
Right, again it depends more on what's called the residence time of the fire than actually the heat put out by the fire, because a very fast moving fire can put out the most amount of heat, but it moves so quickly that it doesn't have a chance to burn down into the ground.
Okay, great. We have another question out there on the phone. Who's out there?
Yeah, hi.
Hi.
Yeah, hi, this is Ike.
Hello, Ike. What's your question?
From Mall, New Jersey.
Oh, New Jersey. What's your question out there in New Jersey?
Yeah, I want to know what was the largest fire, like forest fire in history?
What was the largest forest fire in history? There's a good one.
It probably occurred when there wasn't anybody around to see it.
All right, what about the one that we know about?
Okay, the ones that we've known about here locally, the Yellowstone fires that you mentioned burned something like 3 million acres. I'd have to say that's probably one of the largest single fires that I can recall. But we've had fires in Minnesota here that have burned miles and miles and miles, probably 1 million acres. It was not unusual back in the old days. Nowadays, you know, other than the really bad fire years, very often a fire might, well, most fires actually we catch them before they even get to 1 or 2 acres. But occasionally they'll get up to 100,000 acres or so.
But 3 million is about the biggest we know.
That's about the biggest one lately.
And that's plenty big. Okay, do we have somebody else on the phone out there?
Hi, Peggy.
Hello.
This is the control room, and we have an email message from Ramapo Ridge in New Jersey, and they want to know what are some ways that they can help prevent forest fires.
Okay, how can kids help prevent forest fires?
Well, kind of like what we mentioned, not only that they're careful with their fires, but also if they see somebody who isn't careful, maybe that they tell them, hey, we don't need any extra fires out here.
So not only be responsible with what you do, but also watch what other people are doing.
That's right.
And take care of the forest.
Right.
I mean, it does belong to all of us.
That's right.
So be careful with your own matches and be careful with what other people are doing. Okay, do we have another one out there?
Hello.
Hello.
This is Lisa Thompson from Niles, Michigan.
Hello, Lisa.
I wanted to know, how does the fire hurt the soil?
How does a fire hurt the soil?
How does it hurt the soil?
Does it hurt the soil?
Well, kind of like what I mentioned just a few minutes ago, you can have soil damage done if there's a tremendous amount of fuel sitting on the ground and it's been very dry so that there isn't a lot of moisture in the soil.
But when it's damaged, what actually happens to the soil? Does it kill nutrients, or does it kill roots, or what happens?
Well, it can kill roots, and it also can kill the microbes, which are living creatures down in the soil that help produce those nutrients.
Okay, well that's all the time we have for questions. Now just to recap what we've learned today, fire is natural. It's happened in the forest for thousands and thousands of years. We're just learning how to use it as a management tool. So today we try and manage our forest for wildlife, recreation, and timber, and fire is just one of the tools we have for effective management. Well, I'm ready. I think I'd like to be a firefighter. I may go try that training. That's our show for today. We hope you enjoyed Fire in the Forest, And we look forward to seeing all of you next year when Bell Live explores a pristine trout stream and we discover the importance of fresh water.